Welcome to an overview of networked media systems. Simply put, networked media systems are audio and/or video equipment that reside on an organization's Ethernet network. Traditional AV implementations typically were isolated systems that supported a small number of rooms close together. As a company's AV needs grew, additional isolated systems were installed, often by different AV integrators using different equipment and controls. One end result was higher costs because duplicate hardware was required and there was significant labor involved for pulling miles of cable and conduit. Different hardware used to design and control led to higher training costs and required more time from system administrators to maintain each system. Networked media systems are the natural evolution away from isolated systems and are designed to maximize system resources while making system administration easier. Among the benefits are simplified system design and installation, the ability to share processing resources over the network, flexible methodology, easier expansion into new areas and buildings, and a reduced need for cable, conduit, and equipment, making installations better for the environment. Professional AV signals are typically transmitted over a facility's network using one or more of the following protocols: CobraNet, Dante, and AVB. Developed about 18 years ago, CobraNet is a Layer 2 protocol and can only be used on a local area network since it cannot travel through routers. CobraNet does not require special hardware, and you can use standard network switches that are 100 megabits per second or faster. Of the three protocols, CobraNet has the largest latency and smallest channel count, supporting 32 input and 32 output channels for a total of 64 channels. While this technology continues to be well suited for many applications, larger and more complex installations needed something more robust. Dante was first introduced about 6 years ago. It offers significant advancements over CobraNet in terms of latency and channel count capability, and the most common implementation supports up to 64 input channels and 64 output channels over a gigabit link. Dante is a proprietary Layer 3 protocol and, similar to CobraNet, does not require specialized network hardware. It has full IP routing capabilities and uses standard VoIP-related network switch features to maintain QoS. AVB was developed to provide an answer for installations that require even lower latency and higher channel counts. On a 1 gigabit link, AVB endpoints support hundreds of channels in each direction, and AVB has the capacity to grow with the network beyond that. AVB requires smart switches, which will route AVB streams and maintain QoS requirements automatically. While this may require you to invest in new switches for your network, the smart switches require less programming and administration by IT, which makes them simpler and more cost-effective to manage. And a number of manufacturers already have AVB switches available on the market. While CobraNet, Dante, and AVB are excellent for transmitting digital audio over a network, every installation has unique requirements, and you may want to consider some of these differentiating factors when designing your next networked media system. There are 4 possible configurations of networked media systems regarding the placement of DSP and I/O: centralized, distributed, hybrid, and decentralized. In a centralized configuration, all of the DSP is in one physical location. As the responsibilities for AV and IT continue to converge, it's becoming more common to house the DSP in a server room. By housing the DSP in an unoccupied space, as opposed to, say, a conference room, it becomes easier to perform any necessary maintenance or upgrades. Expansion into new areas is also simplified by having to install I/O endpoints only. A distributed configuration involves multiple physical locations of DSP placed closer to the I/O endpoints and is often utilized in instances where buildings are separated by large distances. In some cases, organizations may entirely prevent audio transport protocols from passing over their WAN connections. Centralized system control, however, can still be maintained via VPN connections. A hybrid configuration takes elements from both a centralized and distributed system. The most unique feature of a hybrid system is that you can have both DSP and I/O at an endpoint. In the case of BIAMP's Tessera family, a server I/O can not only act as an I/O endpoint, but can also serve the DSP needs of other I/O on the system. As with the other configurations, expansion into new areas is still very simple, having to install I/O endpoints only. A decentralized configuration, like BIAMP's Bochia family, puts DSP at all of the endpoints. The system distributes the demand for DSP across the network, sharing resources between devices as required. This configuration is an excellent choice for both critical paging systems and life safety paging systems, each of which have rigorous requirements for system availability and operation in times of emergency. If any device fails or becomes disconnected from the system, the remainder of the system continues to function properly. With networked media systems, the days of multiple, isolated systems and miles of cable are gone. Now remote systems can be combined into a single network that shares processing power and resources. Installations are faster and more cost-effective. Upgrades or expansions are easier, and administrators spend less time maintaining the system.